Good morning, Math 2 students. This is Mr. Flynn. These notes that I'm going to put together for you today, as you can see here, Unit 10, Part 2, Notes for 2020, goes over factoring. Greatest common factor we'll talk about first, then binomials, trinomials, four-term polynomials. The second half of these notes I'll do later, either this week and into next week. So save this sheet. I'll add more problems down here as we go. But to go back over our factoring, just to get it clear in our heads, okay? We always look for the greatest common factor anytime you are factoring, okay? So these first three examples are just going to be greatest common factors. So in example number 1, we have a 3x and we have a 9, okay? So there's no x in both of them, so we don't have a variable that'll come out. So what comes out of 3 and 9? A 3 evenly, okay? That greatest common factor must be part of our answer. So then we go back up and we take 3x divided by 3. The 3's cancel, leaving 1x or just x. Minus 9 divided by 3. That leaves 3. And there's our answer, okay? Again, something we've done quite a bit, but just kind of warming up. Number 2, we have not only a number, but a variable that could be part of our greatest common factor. So we look here, and we have a 4 that can come out of each one, but we have an x in both of them. And we have x to the second and x to the first. So we always take the variable to the lowest power. That'll come out. And so that becomes part of our answer on the outside. And then the 4's cancel. The x leaves just x plus. Now here, don't just cancel this off and you're done. That becomes a 1, okay? And there's your answer. Because when you distribute back in to that last term, you want to get that 4x, okay? So keep that in mind. The last one is to show that when our leading term is negative, we're going to take out a negative number, okay? So if we have a variable and a number that can come out, and the leading term is negative, it has to be a negative number that comes out. I can see a 2 can come out of everything. I have an x to the 5th, an x to the 4th, and an x to the 1st. So I'm going to take an x to the 1st out, and remember, since that leading term is negative, we take a negative out of everything. And I should put those all in, okay? So then negative 2x comes on the outside. The negative 2's cancel. X to the 5th leaves x to the 4th. The 6 divided by negative 2 leaves negative 3. And an x to the 4th and an x leaves x to the 3rd. Negative 8 divided by negative 2 is a positive 4. Remember your positive and negatives when dividing, and the x's cancel themselves out, and there's your answer, okay? Now, the binomials are just greatest common factors, but there's a couple special cases I highlighted here. So again, example number 1, for binomials, which is just 2 terms, 1 term, 2 term, we can take a 5 out of each. So the 5 comes on the outside, leaving 5x, because 25 divided by 5 is 5. And then 15 divided by 5 is 3, minus 3. You're done. In number 2, there's no greatest common factor, but we have what's called, if you remember, the difference of squares. That means we have a perfect square in the first term minus a perfect square. So if you recall the way this can work, now you don't have to show all this work, but I'll show you how this really works. We can make this a trinomial because we can add a 0x term in the middle. Because 0 times x is 0, it's really just nothing there. But what we're saying is, if we take this 64 and list its factors, 1 and 64, 2 and 32, 4 and what's that, 1, 6, is that correct? Yeah, 16. 5 doesn't go into there, 6 doesn't go into there, 7, 8 times 8. Remember, if the last term is negative, the signs are different. One's positive, one's negative. So which one, when added together, give you 0x in the middle? It's that positive 8 and that negative 8 of our factors. So our answer really is x plus 8, x minus 8. You do not have to show this for a difference of squares. You do not have to show this for the difference of squares. You can go right from the original problem down to here. But that's only when it's a difference of perfect squares. Okay? So now here we have a greatest common factor, and it looks like there's a 4 that can come out, and it looks like there's an x that can come out. So when we divide, I'm going to take that 4x. Let's write that part of our answer. Then when we divide this, we're left with just x squared. When we take 16 divided by 4, negative 16 divided by 4, we're left with negative 4, and the x's cancel out. We have a difference of squares in here. And if you recall, we can just go 4x. Okay, 4x. And then this becomes x plus 2 minus 2. Because 2 times 2 is 4, and a positive 2 times negative 2 is that negative 4. Difference of squares, okay? It's our very own special case we're going to see. Now the trinomial factoring, I'm going to go through every single type. If you notice, we're going to look at that last term and its sign, okay? And that's going to tell us something. But I'm going to add a little something in here. When we take that last term and it's positive, okay, it means both the signs of the factors are the same. Same sign. Then we look to here to see what it is, and this tells us it's positive. So we know the factors of 72 are going to be both positive. Now, how did I get the 72? I don't just pull it over from here. Here's what I'm going to add. We're actually going to put a 1 in front of here because the leading coefficient times the last term is really the number we use here. It's just that every single time it's been 1 here. So we just bring the 72 over. Or like an example number 2, we just bring the 5 over. But I'm going to keep mentioning how this is a 1 over here. Okay, and we multiply it, and there's a reason because that number's not always going to be 1 in the future. So let's list our factors of 72. 1 and 72, 2 and 36, 3 goes into there, 24 times. 4 definitely goes into there. Let's go 18 times. 6 goes into there, looks like 12 times, and then 7, 8 goes into there 9 times. There's our factors. Now remember, the signs are the same and they're both positive, so we can just go both positive, both positive. And then, which two pairs here, of these pairs, which one gives us the positive 17 in the middle? And that's the last one here. So we have x plus the 8 from here, and then x plus the 9. And we're done. Okay? So let's move to number 2. 1 times 5 is 5. List the factors of 5 as 1 and 5. The last one is positive, so the signs are the same. But now they're negative. And these two give us that negative 6 in the middle. So I get x minus 1, x minus 5. Okay? Now we move to where that last term is negative, so the signs are different. And this, sorry about that, this one tells us that the largest number of our factors, when we list them, will be positive. So that 1 times 56 is 56. The factors are 1 and 56, 2 and looks like, 28. Looks like 4 goes into there, and let's say it goes into there 14 times. 5, 6, 7, 8 goes into there 7 times, or I should list them correctly. 4, 7 times 8. So the signs are different, and the largest is positive. So I make these all positive, and these all negative. And which two give me a positive 1 in the middle? That's a positive 1x. That's right there. So I have x minus 7, x plus 8. We're done. The last example, before I get into some tougher cases, is the signs are different, and the largest factor is negative. So 1 times 18 is 18. That's 1 in 18, 2 in 9, 3 in 6. So if they're different and the largest ones are negative, the smallest ones are positive, which pair gives me a negative 7 in the middle, right there. So it's x minus 2, x plus 2, x minus 9, and we're done. So what I did with those 4 is go over all kinds, where the signs are positive, then positive and negative, then negative and positive, and then negative and negative. Those are your 4 opportunities. Those are the 4 ways they're going to show up. What I didn't do every single time, which I'm now going to show you on 5 and 6, is we should always be looking for the greatest common factor. Look for a greatest common factor first. And I'll solidify those rules later, but I wanted to just get back into the factory. So if we look for a greatest common factor here, I see a 3 can come out and nothing else. So that 3 is part of our answer, and that leaves me a trinomial. If I divide this all out of x squared plus 3x minus 10. So now this trinomial needs to be factored. So the leading term is a 1. 1 times 10 is 10. That's 1 and 10, 2 and 5. All right. The signs are, let's use a different color here. The signs are different, and the largest one is positive. Which one gives me that positive 3 in the middle? Right here. So don't forget our greatest common factor. And then we have x minus 2, x plus 5. And we're done. The special case on number 6, I'm going to star it, is the leading term is negative. So whatever we factor out, if there's a greatest common factor, we factor out a negative. And it looks like there's a 2 that can come out of everything. So we have to make it a negative 2. So there's a negative 2 that comes out. So when these cancel, it leaves x squared. Negative 18 divided by negative 2 leaves a positive 9. Negative 40 divided by negative 2 leaves a positive 20. Okay, so now I have a trinomial. This term is 1. 1 times the 20 is 20. My factors are 1 and 20, 2 and 10, 4 and 5. The signs are the same, and they're both positive, which two give me that positive 9 in the middle, right there. So our greatest common factor is negative 2. And then we have x plus 4, x plus 5. Okay? So the last one is the 4-term polynomial. And remember, we do that, we factor by grouping. So we group the first, and we group the last. And then we look for greatest common factors in the first group. In the first group, it looks like there's an x squared. So we take the x squared out, and that leaves 3x. That leaves plus 2. Now, we always look what that sign is of that second front, or that second group. It's positive, so we're going to take a positive out. So we're going to take a positive, it looks like 3. And so that leaves 3x plus 2. And if it works correctly, you should have the same thing in here as in here. Oop, I'm sorry, I made a little mistake. Let's clean this up. I forgot to write my common factor back here. Was that 3? And that left 3x plus 2. And now that's there. So these two, I'm actually doing another I'm going to factor that group out. And that leaves x squared plus 3. And you're done. Okay? And then the last one, same thing. Factor this group, but notice there's a negative here. So in the first group, we can take a 3x squared out. 3x squared out. So take that 3x squared out, and that leaves x. Take the 3, leaves plus 2. I'm going to take a negative, and it looks like 2. So that leaves x and positive 2, because negative 4 divided by negative 2. So what happens is, notice these are the same, factor that out. All right, oh, I've made my same mistake again. Let me back up here. I'm going to redo this whole problem for you, because I'm trying to go too quick here. I'm going to factor this. I'm going to factor this. So I have a 3x squared and a 3x squared. And that becomes 3x squared on the outside, leaving x. 3x squared leaves 2. Now, what am I factoring out here? I'm factoring a negative 2 out. So I have to divide by negative 2, divide by negative 2. And that leaves x. Negative 4 divided by negative 2 leaves a positive 2. And if you notice again, the same thing is in there. We'll factor that out. 3x squared minus 2 is left. Okay? Hopefully that's all the factoring we'll be dealing with. We'll get some more complicated problems at times, but we're going to move into this more later this week. All right? If you have any questions, let me know. Let Mr. Files know if you're in third hour. Let Mr. Owens know if you're in 8-9, or Miss Manglardi. All right? Have a great